Okay, so we're back with 2015 Junior Cert Technical Graph Higher Level Section B. Question 2, which is the rotation question, as we spoke about in class. Now, the elevation, end view, and a 3D graphic of a sign for a fish shop are shown. So here's your elevation, here's your end view, the vertical line, and there's your 3D graphic of the fish shop. The sign is based on a regular hexagon ABCDEF. So ABCDEF, regular hexagon means all 6 sides are the same length, and an equilateral triangle DGH. So DGH, equilateral, lateral is the side, so equal sides, so they are 3 sides of the same length. And of course an equilateral triangle is also an equiangular, meaning the 3 of them are 60. Okay? Draw the given elevation and end view. Now, to draw the given elevation, it's pretty simple, right? You have your height, add the 3 of them, you get your total height, 40. Elevation, here's your end view. Right? Then your width is 35 and 40, which is 75, and 75, which is 150, as shown. Okay? So 150 by, now, then you can join this bottom point here, which is your start, right? And you can just forget about, that was just for the class to locate it on the sheet, where to put it, right? Bottom point, which is here, joins up to this point, which is over on the right and up 40, which we did. Then it goes from where this line that's in 35 coming down there, cuts it, it goes up 30 degrees there, right? So that's 30 degrees, 130 high degrees off of that line. Okay? Now, so again, just to show you there now that you can actually see it, that's 40, 35, 55, then that's 35, 40, 40, 35, so 150 by 130. Now, so that line is joined back up to that point, that one up 30 degrees. Now, in question 2, like with the transformation question in question 6, there's quite often it comes up where you have to do an enlargement, okay? Where you'll have a shape like we have here, we have a hexagon with an equilateral triangle onto it. Now, if you were just asked to draw a regular hexagon with an equilateral, you could draw it no problem, very simple. You pick whatever distance you want, draw the hexagon, come across there, come across there. The fact that we know that that's 60 degrees altogether means that the top part only is 30, so you come up at 30 till it hits the line coming across there, and then you'll be able to draw that. So it's easy draw it. What we had to do here is, you can see it here, lightly. I did a small one first, then you enlarge it. You have corner A, you know that corner G is over 80. So over from A here, 80 over, we had this light line here where the pencil is. So I'll zoom in there for a second and you'll be able to see a small, right? So look, I just marked with a black point. So that's where we initially drew the hexagon. The regular hexagon, any size we want, and then the regular. Then this, the furthest top right hand point G, I know if I go out from A through that point until I hit this point here, which is the real G, which is over 80, that then gives me where G is, and then I can work back. I know that that's a 60 degrees there, right? This angle there is 60, so bring that down to 30, and then where that crosses the midline, you can join the back, and then you go up 60 degrees, 60 horizontally across. Use your compass there to get your rate, and that's your hexagon. Now, so now that we've got drawn, okay. Well, apart from the curve, of course, and the curve is pretty simple. Down to the very bottom point, 45. Draw your semi, so that's the bottom point in the center, 45. And then the center there is over 40 from A in the middle, that's the center, and the circle is radius 50, so that's that circle. Now the end view, of course, does not start on the bottom, because the sign does not start on the bottom, so that's brought straight across. That's your center for O, which will be your center of rotation there, and then that's the top, right? Now, we know that it's 45 degrees there, well then that obviously, of course, because opposite angles are equal, that's 45 and that's 45, okay? So I'll bring my 45 degree line through O, like that, right? Now, then what you decide is, okay, I'm going to bring the top 2 points of the sign, which are here down, and the bottom point, which is here up. Okay, so I open my compass from my center of rotation, which is O. I open it out to the edge there. Right, scribe that down. So this is where the top 2 points are when the sign is rotated. I'm going to have to zoom out a slightly here now so we get the other side. So here, that's the bottom of the sign, and that's rotated out there. Right? So now, in my new end view, the sign is there to there. Okay, that's my new end view. Now, we now have to draw a plan down here, okay? So, draw the sign is rotated 245 degrees about to point over the line. Project a plan to show the sign in rotated position. Now, first of all, I'll just do the outline of the actual sign itself before we do these 6, 7, 8 points to draw that and your curve. We'll just do the sign. So, using my red marker or my red biro, I'm going to name the outside points 1, 2, 3, 4, and 5. Okay? Now, I have 1 and 2 here. They're rotated there. That's where 1 and 2 is now, when in the rotated position. Then 4 is here. That's where 4 is when it's rotated up. Right? Now, what I'll get next is 5 and 3. So you bring them straight across. First of all, the same like we've done in the rest of the questions. First of all, you get them where they are before the thing is rotated. Then you rotate it around. Now, I'm also just going to correspond my view here. So look, that's going to be 1 as we said there. This here is point over a door, point over a tree, over a car, obviously over a Coogan shot. Right? Then 1 and 2, this there, that's the point where 1 and 2 is when the sign is upright. Then it's swung down. And the distance from where it's hinged will never change. So we use our compass to get 1 and 2 in the new position. Same, this is 4, rotated up. This is where 4 is now. Now, next then we'll bring 3 and 5 across, so 5 is across there, and 3 is across there, right? So that's where 5 and 3 is, before rotation. That's 5, it's 3. Now, then you have to rotate them out because the sign is swiveled. Rotate, so bring 3 up like that, and bring 5 up like that. Now, that's 5 and that's 3. Now, what we do then is, like any point in plan, right, we have to project a plan to show the sign in the rotated position. If we were drawing a plan of the sign before it's rotated, what do you think it would be? It would be a line here parallel with your XY axis. What would represent as a horizontal line. It's just a vertical sign here, right? And it's not shown any width because it's just represented as a line. So if it's just a vertical line from the side, then as we go above, look down, we just see the top there, which is just a horizontal line, or a line parallel with your vertical plane. Now, as it's rotated, we're going to see all of these points. But it's looking there, we're looking perpendicular, so that's the true length. But here in the plan, we'll be looking down on top, so we'll see it as this length here, which of course is not a true length. Now, as normal, from the bottom left-hand point here of my elevation, I'm going to bring a line out at 45 degrees. I'm going to have to start zooming out a bit now so you can see. Unfortunately, I'll try to keep it as close as we can, where we can still see everything. Now, first of all, I have to remember now that it's these points on the curve line, right? Not the ones that are on my actual end view, it's when it's the end view is twisted. So, I'll bring 4 down, I'll bring 1 and 2 down, I'll project 1 and 2 across, so I know 1 and 2 is there. I'll project 4 across, and while I'm doing it, I'll also bring 3 and 5 down. So that's where 5 is, that's where 3 is. Right, then project them across, so 3 is projected across there, and 5 is projected across there. Now, what is on this point? 1, right? So 1 will be down here, so this is point 1 now in my new view. Oh, so I have to project it down first. Oops. So 1 and 5 are going to be down on that line. 4 will be down on this line. Now unconsciously he told me in the other ones we were too slow, so I'll try and move a bit quicker now. You can always pause it if it gets too confused for you. Now, so as we said, 1 is down and across to where it meets 1, so that's 1 in its new position. 2 is with it, across there, where 2 comes down, that's point 2. So this is the line 1, 2 in its rotated position in plan. Then 1 drops down to 5, so 5 will be down here somewhere. There's 5 in the end view. That's point 5. That will go to point 4, which is straight down from 4, which is there. And then that will go to point 3, which is 3 comes down and over. This is point 3 here. Okay. So 1 and 5 join like this, 2 and 3, vertical line like this, and then we join 4 up to 5 and 3 to 4. Nice and simple. Now, for the hexagon and the triangle, I'm going to switch to green. Good care colours. So, I have A, that's where I know A is. Now, if I go back to the diagram that we got at the start, I'll follow these, right? So we have B here, C, D, E, and F, right? This is following these, and then G and H up here. So this is G and H, alright? Now, again, what do we have to do now? Like the rest of them. First of all, we find where them points are in the end view before any rotation occurs. So to find where any point is in the end view, it'll be the same height, and these are all on a plane object, meaning it's got no width. So the 3 points there, B, C, and G, will be there. A and D will be at O, so they'll actually remain in the exact same place in rotation. And E, F, and H are here. So this point here is B, C, and G all together. B, comma C, comma G. Right, that's a pretty rough looking B. B, C, G. Then F, E, H is here. Right. Now again, that's the end view before the sign is rotated. Now the sign is rotated. So I have to go back and get my compass. I open it up to BCG, rotate that down, and here, rotate that up. Right? Now, that means now that B, C, and G are now actually on this line. B, comma C, comma G. And F, E, H are actually on this one. F, comma E, comma H. So now it's, remember, it's on the rotated line, right? And it's important. So what I'll do is, to make sure and emphasize that it's the rotated line that we use for our plan, I'm just going to put it a bit heavier here so that you can see that's the important one now that we're dealing with. Okay? Now, like any other points we've ever got, A in plan will be directly underneath A. F and E, or F and B rather, will be directly underneath each other here. C and E will be directly down here. D will be here. And G and H will be here. Now, then B, C, and G, take it straight down. This is the point here. Take that over. So, on this line now lies B, C, and G. There's B. There's C. Right? Sorry. And then G is over there. Okay? Now, F, E, and H then, rotate it up. So we'll bring that down. F, E, and H is rotated down. Brought across. And again, F is under B, so that's F. E is underneath C, so that's E. And H is underneath G. Now, then B, C are joined, horizontal line there to there. E and F are joined. G, H is a vertical line. Excuse me. Now the 3 points we're missing, or the 2 points we're missing here are A and D, right? Now A and D, when they go over, are with O here, right? Because they're actually on the hinge of rotation. In other words, they're basically all on. Look, the 3 of them there, them 3 points, or them 2 points, sorry, A and D, right, are on your axis here that the sign is flipped about. So they are straight there, so I'll come straight down, straight across, come down. I've already come down, so that's A straight down, that's A here, and that there is D brought down. So I'll put it there now because there'll be lines going at angles there. So obviously it doesn't appear as a regular hexagon now because we're not looking perpendicular to it. Right, so and the line here goes A to B and A to F, so here it'll go A to B, A to F. That won't change. F to E, B to C, C to D, and E to D. And finally then D goes over to G, and D goes down to H. Okay? Now, nearly complete. Last thing to do is the circle, right? And of course, right, what will be the first ones? You find the two of them, right? Because they are both on your center line here. So this center line going across there will contain the two outside points of the circles. Similarly, our center line, we have our two, right? So we'll go bring them out, swivel them, bring them down, bring them across. Now the best way to do a circle is to divide up like you would an ellipse, right? What I'm going to do now is I'm just going to put in heavy here, that point. Why? Because that's the center of our circle. So how many points do we want to get? We'll do, generally when it's a large circle like this, do what you do for an ellipse, right? So come down through there. I have vertical of course already, silly me, through there. And go this 60 degrees up through there, and finally we will go this degree here. Right? Now, and again, spice it up a little bit. We'll change the old colours again for this part. And we will use the start, I suppose, where we normally would. Start at this point. 1, 2, 3, oh, wrong one there. 4, 5, and underneath the middle here, 6, right, and make sure it's directly underneath the middle, 7, 8, 9, 10, 11, 12, alright. Sorry about that little mess there. Now I have no Tipp-Ex to get rid of it, but just forget about it. Now, then find the 12 of them over here first, right? And the beauty about 30-60 means that 1 and 11 are parallel, 10 and 2 are on the same line, 4 and 8, and 5 and 7. So 1 and 11 are brought across there, 2 and 10 are brought across there, 9 and 3, I know they're already on that line, so I don't need to bring them across. 8 and 4 are over there, 5 and 7 are there, right? Now, and 6 of course, I forgot 12 and 6, oops. 12 across there, and bring 6 across there. Now, so top point 12, next one 1, 11, next one 2 and 10, next one 9 and 3, next one 4 and 8, next one 5 and 7 there, and the next one 6 on the bottom. Now I probably should have used different numbers than the 1, 2, 3, the red, but to be fair, the difference between blue and red should be distinct. Now, of course, the ones above O are rotated to the right hand side of our end view. So that means that 12 in its new position will be there. 1 and 11 will be on that line. 2 and 10 will be at this point. Here, 4 and 8 will be there. 5 and 7 will be there, and 6 will be blue 6, right? So now, blue 12 is here, blue 1 and 11 is there, blue 2 and 10 are there, 9 and 3 will stay as they are, 4, 8 is rotated up here, so this becomes 4 and 8, 5 and 7 is rotated up to there, 6 is rotated up to here. Now, again, where will these blue points be in plan? They'll be directly under the corresponding point in elevation. So 9 will be down here. And again, the beauty of 30-60 means that these will all be in line too. So 10 and 8, right? 11 and 7, 12 and 6, 1 and 5, 2 and 4, and 3, right? Now, before I bring down any of these, I already have which ones, right? What points can I bring down, or do I have brought down already? And of course, they are 9 and 3. 9 and 3 are here. That's brought down in here. So 9 is brought down. That's point 9. 3 is brought down. That's 0.3. Right? Now, what I need to do now is I need to bring the blue ones down in the rotated position, bring them down here to go across. So what I'll do is, I showed you this the other day, when you've come to the point where there's a lot of them and you want to distinguish these, just little line there. So I know that's the 6, that's 5 and 7, just little line to mark it. This is 4 and 8, make it a bit heavier. 9 and 3 is done. 2 and 10, 1 and 11, and 12. Right? Now, of course, the other way, and what you can do with all of them if you want, for example, is you could mark that as 6, mark that as 5, 7, mark that as 4, 8. You know that 9 and 3 are there anyway. This one here then is 2 and 10. This one is 1 and 11. And finally, Iverdodiag 12 is there. Now you can do that, you can bring all your greens and all your reds down and mark them there if you want. You don't have to. But as you do more and more, it gets a bit complicated. It's no harm to either mark them with a line or mark them as the points. So now, 12 comes across here, right? And where is 12 at the top? It's right in the middle, so I join down. That there is point 12. Right? Then 1 and 11, bring it across. Right? 11 is there. That's point 11. And that one is directly underneath 1. Then 2 and 10 are here. Right? So 10 is down. That's 10. That's 2. That's 10. That's 2. And then 8 and 4, which is here. Right? So this is 4 and 8 there. This point. 8 is directly under 10, so that's 8 there. 4 then is directly underneath number 2, which will be over there. That's 4. Then it's 5 and 7. Rotate it up, brought down, project it across. And 5 is under 11, so that'll be 5. Or that'll be 7, I beg your pardon. 7 is underneath 11 there. And 5 is underneath 1 there. That'll be 5. And finally then, the last one of course is Iverashay, number 6, which is directly underneath 12, which is there. Right? And it goes very close to the line of the curve because it goes very close there. So there's now our ellipse, right? Remember, if you look perpendicular to it, it's a circle. The second it rotates off center, it's an ellipse. Now, to do that curve, it's freehand, right? So again, freehand curve is something you need to practice, right? Principle, you're always bringing the graphite towards your wrist. You're not bringing it away because that's the natural shape. And that can affect the height of it, such as the T-square. Knock that out of the way, or put it out of the way rather. So then you've, right, and you kind of, now never try, so look, don't stop at 9 there. Always try to bring the curve a slight bit through it. And then you move around. Right, and what I do, of course, as you'd see me doing classes, I swivel the board, but for demonstrative purposes. Oh, I'm going to move it because I can't reach the other side of it, so I'll make sure that you can still see here what's happening. So. Back. Really never working envelope again. So I just finished that freehand curve now. Alright, so go ahead. Next stop Hollywood, sir. Right, so that completes the curve, the full freehand curve then. And the very last step, the only thing we're missing in our new plan here in the rotated position is this curve here, right? So I'm kind of running out of colours to use, so we'll just use black. We've 2 points straight away that are on the curve, right? So we've gone as far as GH, right? I'll call this HI. Then we'll pick a point here, J. And again, the reason why I'm using my T-square to go across from J is so that the other point will be in the same position when we need to rotate it here in the end view. We'll put K in the center, L there, and finally this point out here is M. So, very simple, get I and M. We know they're on the curve, so we can project M straight down. I comes straight down here. That's I in plan. M comes straight down here. That's M in plan. I'll mark them in. Follow I down. That's I. Follow M down. That's M. Now I have the line brought down for K already, so K will be the first one I'll get. So again, like all the rest of the points, you find it first of all in the end view when it's not rotated. So this is where K is when it's vertical. Then it's rotated around, so you use your compass, put the point on the center of rotation, open the K, swivel around. This is where K is in the rotated position. Then as normal, project K down to the line, go across horizontally, and we now have the line where K comes down, goes across, comes straight down from where K is there. That then is point K here in our plan. Now the only two we're missing to finish this freehand curve down here is J and L. Again, same step with every one of the rest of the points. First of all, you locate J and L in the position before it's rotated. There. Then we rotate it out. Now it's obviously more or less on 3 there, but we'll still do the procedure on it. Slight bit, or maybe. Because I just picked the height of J and L random there, that just ended up being beside 3, the same height as 3. So then there's J and L there. Project J and L down then. And again, of course, it's nearly at 3 the whole way and project it across. Now, it's pretty high there close to the, so it's only going to be a small bit below K there, but again, J is brought down to this point here, brought across. Oh yeah, we to project J and L down, sorry. J comes down there, L comes down there, and then and J and L there, project it across. This is J there, and this is L there. So this is J at this point, this is L, then I can do my freehand curve IJKLM to finish the question. So again, try using natural movement back towards the wrist. You do it lightly first of all. And when you're happy with it, you can heavy it in. So again, that's that question done. 2015 Junior Cert Graph Higher Level Section B, question 2. Right, and again the key to every question is the usual principles. First of all, think about it. Visualize it first in your head where you're going to locate the things on the sheet, right? We knew we were doing a plan, we knew we'd be going under this, so we were keeping the elevation and end view as naturally on top. Also, think about the fact that this is going to be rotated. When you're drawing your vertical end view, don't put it right beside the elevation or you'll end up rotating back onto the elevation. So we left a gap at 50, and it worked out pretty well. You could have maybe left 60 or 70 for more space. Also, the key to them as well, indexing the points. Any point you have in the elevation, the corresponding point in plan is directly below. The first end view, the one we were given that we had to draw, was vertical, then it's rotated about point O. So any points here have to be found in its initial position first, then rotated so it's in the rotated position, and then your normal routine to finish. If you V here and you V here, straight down, rotate it straight down and across, and that's there. And don't forget also the method of enlargement to find the regular hexagon with the equilateral triangle. Do it any size first, then use the enlargement out through. We knew G was 80 away, this line here was 80 away from the vertical line containing A. project that out till it hits it, that gives you G. Then you can work back. We knew that was 30 degrees in there, so we could come down from G to find D. Then we could come that way and come down to find H, and then we could finish it. So thanks for watching.